In this video, I'm going to walk through the solution to question number 3 from the Chapter 10 problem solving set. So in this question, we are asked to synthesize a couple of different alcohol molecules by using a Grignard reagent reacted with formaldehyde. So what we're really asking here to provide kind of a pictorial of this is if we took some Grignard reagent, which our job will be to figure out exactly what Grignard reagent that is, reacted with formaldehyde. Remember, formaldehyde is a 1-carbon aldehyde. It's really useful for synthesizing primary alcohols in these Grignard reactions with aldehyde. So reacting a Grignard reagent with formaldehyde, we want to ask what structure of Grignard reagent can we use here in order for our product of this reaction to be isopentanol. So isopentanol, we need to be able to draw the structure of. The term pentanol means there's 5 carbons in total in this alcohol molecule. And the term iso indicates to us that at the next to the last carbon atom here, as we go away from the alcohol group, we have a methyl group there. So we have 5 carbons in total. You could also refer to this molecule as 3-methyl-butan-1-ol as well. So we need to ask, what would the structure of the Grignard reagent be that would allow us to accomplish this? So keep in mind carbon conservation first off. So formaldehyde contributes 1 carbon to our count here. We need 5 carbon atoms in total. And so we have to think backwards here to what would the structural arrangement of those 5 carbon atoms be in our Grignard reagent, or 4 carbon atoms in our Grignard reagent rather, because we have 5 carbons total in our count here in our final product. 1 of those carbons originates from formaldehyde. That means that our Grignard reagent has to have 4 carbon atoms to give us our grand total of 5 carbons. So what is the structural arrangement of that going to be? Well, when we think backwards about the relationship between the structure of the product and the structure of the reactant here, we can piece out that the formaldehyde, the 1-carbon chain here, and that carbonyl group is what becomes the last carbon here of the chain and ultimately the hydroxy group. So the part that I've highlighted in green here is what's going to correspond to this part. So it's going to be the rest of the molecule that will correspond to our Grignard reagent, which I'm going to label that as GR to indicate that's what has to originate from our Grignard reagent, is going to be the 4 carbon atoms we've highlighted here. And to get this to work out correctly, if we make our 4 carbon atoms like so, and then plug, for this to be a Grignard reagent, we have to have magnesium there, bonded to a halogen such as chlorine. So we would then have, in total, our 4 carbon atoms here, 1, 2, 3, 4, our 5th carbon right there, and sketching out that the reaction would work out to plan. We keep in mind that this bond here that I'm showing in black is very, very polarized, with the carbon being negatively polarized, magnesium being positively polarized, to such a great extent that we could really think of the electrons from that black bond being the possession of the carbon atom here that's so negatively polarized. So that carbon really acts as a carbanion, highly nucleophilic, comes in, attacks the positively polarized carbon here, pi bond goes up onto the oxygen, and that would give us, as a consequence of that step, I'm going to show my newly formed bond here in red, and then I'm going to show what originated from the formaldehyde in blue. We'd have a 1-carbon chain there, originating from formaldehyde with the oxygen anion. And then we had our 3 carbons, 1, 2, 3, and the 4th one there. 1, 2, 3, and the 4th one there. Our new covalent bond gives us this. And then if we were going to finish this off and get all the way to that alcohol, we would need to bring in a source of acid to protonate that. So the Grignard reagent structure that we would use for this, and what the question is really asking you for here at the heart of it, is this structure right here. So that structure I'm highlighting in yellow is what you would absolutely need to fill in here to suffice what the question is asking. What Grignard reagent would you use to synthesize the following alcohol? So it would be that structure. We can do the same thing down here on our second problem. We're again asked to take formaldehyde as our starting structure and react that with some Grignard reagent in order to yield the alkenol product that is shown here. And formaldehyde is a great way, a great building block for creation of primary alcohol. So we confirm that this is a primary alcohol because there's only one carbon directly bonded to our carbon that's part of the alcohol group. And so we'll take formaldehyde. That will contribute, as we saw up top there. The formaldehyde will contribute the one carbon atom and the oxygen for the hydroxy group. So it's going to be this part right here. And then the part that will be derived from the Grignard reagent is going to have to be the rest of this. So that's going to be our 5-carbon ring there is what's derived from the Grignard reagent. And so we work backwards here and we say, all right, well, the 5-carbon ring with the alkene group is derived from the Grignard reagent, and that's the place where we're going to form the link. Has to be the carbon of the ring that is bonded to the magnesium and the halogen, which I'll use bromine here just to keep things mixed up a bit. Then, making sure this is going to work out and that this is indeed the correct Grignard reagent to start with, we can show that we would take our bond there, bring it over to attack the electrophilic carbonyl. That would force the pi electrons up onto the oxygen atom. And then we could draw out the product that would result from this. I'm going to show my new bond here in green. So you have that new bond in green, and then connected to the blue CH2 from formaldehyde because we have the 2 hydrogen atoms for formaldehyde here and here. And then our oxygen was still connected there by a single bond, so we'd use CH2O minus, and then to go from there to the final product, we would just pronate to bring in your acid. And so going back to what the question's asking for here, it's asking for the Grignard reagent, so that's going to be our structure that we see highlighted in yellow there.